Okay, welcome back to my bench. Today I got here, I have a Harman Kardon HK 690i. I bought this on eBay with the intention of going through, get it working, and put a receiver in my living room. I think this would fit the bill nice. It's got 60 watts of channel into 8 ohms, 100 watts of channel into 4 ohms. I doubt I'll ever use that much power, but you know, it's very capable. And it's got a lot of nice features. If I'm not mistaken, this might be the top of the line HK for that era. But this thing needs a lot of love. I bought it on eBay with the seller saying, "Oh, it works great. Just needs new caps maybe and some pots cleaned up." But boy, does it need needs a little bit more than that, I think. Let's go through and test out what we have here. So I turn the power on. I got speakers hooked up. I have about a 4-foot chunk of wire hooked up for an FM antenna, and I am feeding it right now with 200 hertz into the auxiliary inputs. But let's just see how this works with what's going on here. Looks like all the lights are going on. A little bit while for a protection circuit to kick in. It's quite scratchy pot. Oh yeah, and look at this. Some nice, need some glue on that knob. Pretty scratchy. And I'm mainly hearing out of the right channel. The left channel seems pretty quiet. Let's try. Can you hear that? It's turned right to 0.
Beef and cheddar, a crispy fish, or a classic roast beef sandwich, or just get
okay, so that's the right channel.
$8. We'll call one.
There's the left channel. It sounds very muffled and quiet. I think I got some problems with caps in this thing. Either it's a decoupling cap maybe is dried out, or a bypass cap is shorting the ground. But it's just not putting out
and a massage
the same as the right channel.
Unlimited foot rubs.
Well, just about everything.
Another thing I'm noticing here is I got no signal strength on the FM. It says it's tuned and it says it's in stereo, but I got no signal strength. Let's turn it to auto. It won't go to auto. It stays on manual. Okay, so let's go find another station. 102.9. Now it won't tune.
Get an additional $1,000 bonus cash. It's like having your cake and I can't. Get yours.
So either these switches are very dirty, or there's something electrically wrong with the tuning on this. It's all messed up here. Can't tune up, but it tunes down. Okay, let's go right around. Auto doesn't work. These switches have two detents, where you push it part way to move one space or one tick, or you can push it down, hold it, and there's another click. See, I can press it once, it moves. If I press and hold it, it moves fast. Wow. Okay, let's try with the AM. Same thing, it doesn't go up, but it goes down. And I have no AM signal here. Should be a station right at this, if you can see. hook up an antenna and see if this does anything different. There's no built-in antenna on the back. I'm just picking up noise from my bench. No signal at all. 880 should be another one. No, nothing. So AM tuner's pooched, FM tuner's barely working. Pure tone sine wave. Right channel seems okay. Left channel coming back a little bit after it's been on a while. It seems like it's starting to. Let's try a different frequency. Let's try something high. Let's go up to okay, 1 kilohertz. And nothing on the left. Or very little. Let's turn this up to 5 kilohertz. Right channel. Left channel, there's nothing there. I hit mono. Doesn't seem to make any difference. So this defect is somewhere past the mono switch, beyond the mono switch, probably towards the power amplifier. So it looks like I got a lot of work to do on this thing. I'll test out the phono maybe. No, I don't have it wired up for phono. There's FM now. Sounds terrible. Remove the antenna. Okay, so there's a little intro to what I'm looking up. I got a lot of work to do on this. I got caps all ordered. Some of these caps here. Let's see, I got a pointing stick. Like this one, for example, it looks like it has a stain around it. So maybe that cap is leaked. Some of these caps look like they've been roasted. Right here, especially, there's a voltage regulator here. And any caps usually in this area get roasted over time. It looks like it's been on a workhorse type receiver where it's been sitting on all the time. And these boards get roasted. You can see they change color. They go from that tan brown to a darker brown around where there's any heat. And you don't see that on a receiver that's only turned on when it's listened to, as opposed to one that's just turned on for background music and sits on continuously. So I'll have to go through this and figure out what's wrong with these tuners. Nothing's running hot down here. Yeah, it's going to be a challenge, this one. There's quite a bit of stuff stuffed into this cabinet, this chassis. Probably what I'll do is I'll go through and recap everything first and check all the solder connections and solder joints, make sure there's no cracked joints. Clean it up. It really needs a good cleaning. It's got dust everywhere, and it's got a kind of a funky smell, like chicken soup or something. You know how some people's habitation it has a funny smell sometimes after a while, and it picks up that smell. But it needs a good cleaning, and I'll go through that first, cleaning and recapping, and then we'll start troubleshooting if the need be. Looks like we're gonna have to do something with this volume control. Either remove it, clean it, or disassemble it and clean it. So yeah, I got some work cut out for me here. Might as well just crack on. Okay, so just started here, and I have the tuner board out, and I removed the bottom shield, and already I'm starting to find problems. This pointy stick, here we go. This header here, there's a header that connects to this. I don't know, is it a 20 pin header? And this goes directly to the printed circuit board on the front panel that controls the tuning up and down, the pre-select stations, and a few other things. And there's cracked solder joints on these connections here on this header. There's quite a few of them. So I'll get that cleaned up. This feeds directly into the chip, telling the chip, giving it instructions on what to do with regards to tuning. So yeah, it's surprising. Doesn't take much. See, I got one cracked there, and that is for the signal display. But we're going to go through and we're going to go with a fine-tooth comb. We're going to look at all these connections. Just because this receiver is, you know, fairly old, I'm looking here and I got an 84 date code, another 84 date code, another 84 date code. So this thing was made obviously late 1984. But yeah, we'll get through, we'll clean this up. I'm going to start checking the ESR and all these caps, but I think I'm going to replace the majority of them. Looks like some of them are leaking. This one here especially. I don't know if you can see that. It's got some light on it. You see there's a stain around this one. So I suspect that one's leaking. Yes, it is. You can see right up in there, there's a green cheese underneath the legs. So, go through. Curious to see the ESR meter on some of these caps, just to see how they've aged. Like I said, I suspect this thing's been just turned on and left on for background noise, and you know, it's seen a lot of hours. Okay, I'm just working my way through this receiver, finding lots of stuff. Oh boy. This tuner board, for example, disassembled it, and found, like I said, I found some not cold solder, but cracked solder joints, especially around the header for the connectors. There's connectors here, and also I found some on the integrated circuits. Some of the larger integrated circuits, the ones that dissipate a fair amount of heat. What they do is they start cracking from the outside pins, working their way in as the, you know, it goes through the heat cool cycles. Especially on the big chip, you get a lot of that. It's a microscopic movement, but it's still enough to make that crack. So I'm about halfway through changing caps on this. I'm just still waiting for my order that I placed for the rest of the caps. Another thing is the voltage regulator. There's a transistor here, a PNP transistor, is in a voltage regulator configuration, and the heatsink compound was completely dried and caked up on that. So I replaced the heatsink compound, and I thinned out this heatsink just to give it a little bit better dissipation, maybe to keep it cooler. So that's about it for that. Get this out of the way. And I'm digging through the rest of the chassis, and this is the input board for phono auxiliary tape 1 and 2, and man oh man, this board was placed upside down, and a lot of these transistors must dissipate a lot of heat because this has all been roasted around here. You can see the board has changed from a light tan color to a darker brown, and all these caps, I haven't tested any of them yet, but a lot of them are suspect for being dried out. Oh, Another thing I found on here is I found, I think it was 3 leaking capacitors. And so I'm just going to go through and change them all. So better safe than sorry. If I'm finding leaky capacitors on this tuner board, I'm sure to find some more elsewhere. And here, for example, I got there is a couple transistors here in a regulator configuration, probably a plus minus supply for the board, and all of these transistor solder joints are cracked. And yeah, it's not pretty. It's amazing this thing even worked. So I'll go through and resolder these boards. This is the phono preamp equalizer board, and it's kind of encapsulated. I don't know if I'll open it. I probably will open it. It seems like they got the caps on the outside for the technician to change, so there's no need to reopen this. I'll look at the schematic. If there's any caps in there, I'll open it up. Okay, still working my way through this Harman Kardon receiver. I'm finding a lot of bad caps. I'm finding a lot of cracked solder joints. I think it's mostly due to this thing sat turned on for, I'm guessing, thousands of hours, and you know, it's the heat that does all this damage. The long heat, all these capacitors. So I'm just taking this front chassis plate off to get access to a lot of these boards I can't get at. So I removed a whole pile of screws, removed the volume control and the nuts from the other pots, and I think it's time for this to come apart. If I can get this to cooperate. There we go. Now I can just remove this switchboard for the tuner. And that comes off. Now I got full access to these printed circuit boards. I can go through and check all these solder connections and replace all these caps. There's some caps under here. This gives me full access now. And then there's another board I need access to. Yeah, so I'll just keep working my way through this, going through one board at a time here. And every board I encounter something faulty, which is mainly the cracked solder joints on the PCB boards. These are single-sided PCBs and 35 years old. I'm guessing a lot of heat cycling because there's a lot of cracking around these transistor bases. These 2 capacitors, one is completely, one side is completely cracked and broken through, and the same with this capacitor. I changed the capacitor down here. It had a high ESR of 200 and some ohms when it was supposed to be like maybe less than an ohm. And here's another example I found. There's 2 caps here. This one measures an ESR of 0.36, which is within range, and then his companion here on the other channel, this one measures 7.5 ohms. So definitely a lot of bad caps in this receiver. I'm going to go through and change them all just for the course of that they're getting old, and we can't trust them anymore. So yeah, this thing needs a total recap, and I have to disassemble everything, and I have to check every board and resolder all these connections, because like this one, for example, there was a crack on one of these pins and one of these pins, and that's all going to degrade from the experience of operating this. Okay, let's get down to this volume control pot. I removed it from the board. It looks like it can come apart. So let's see what we can do with this. Either clean it. I don't think I'll find a replacement. There's a part number on this thing. I don't know if you can see that. It's made by It's 100K pot times 2. Let's see what we can do here. It's still held in by the shaft. I think there's might be a C-clip or an E-clip behind this. Let's see if I can open this up. Well, so much for trying to save the label. Yeah, there's definitely a clip in there, and I don't think I can remove it. If you can see that, there's a spring. Open this up. Some light in there. Definitely a spring push-on nut to hold that shaft in place. I don't think I can get it out without destroying it. So at this point, I think all I'm left with is spraying in cleaner. And I'll have to seal this back up. So probably get it right from here. That's probably what these ports are for. This is just... Okay, got it, good. One thing about this pot is that it's got a lot of viscosity on the lubricant, so it's really stiff to turn. It gives it that feel on the knob, but if you hit it with the cleaner, you could destroy that, wash all that lubricant out there. But actually, you know what? Let's make life easy. I guess we don't need this anymore. Let's give it some more. I googled the part number and nothing came up. So, I don't know. Finding a replacement would be an Alps switch or Alps pot like this. Unless I went through Harman Kardon. We'll see how badly this crackles after I'm done. I was hoping I could open it up and then take some cotton swabs and clean it out properly. Okay, I'll leave it at that. Let's install this back in the receiver. I finished all the caps. Here's a little teaser of what I took out. I pretty much did the entire receiver because a lot of them are garbage. These 2250 volt caps I replaced because there was 4 of these in the power amplifier circuit, and I didn't want a chance having one of the 4 caps being out of spec and doing something weird to the biasing alignment of the amplifier. A lot of these caps here, these TK ones, complete garbage. Like, really, seriously? You put this garbage in your Harman Kardon receiver? You should be ashamed of yourselves. There was a high number of, like, this one feels like it's hollow. There's nothing in it. A high number of caps were bad, and so yeah, I just chose to eliminate all of them, put all new, brand new. So let's get this all back together, then we can start doing some testing. Okay, I got it assembled enough. I just slapped this on here so that I can read the switches. I got it assembled enough so that I can test the amplifier, the tuner, inputs, and just to see what's all working here and what's not. So I got it plugged in. I'm feeding it a 30 hertz signal. I got an antenna hooked up. I got speakers hooked up. I'm all ready to go. I'm ready to do first power up. So here we go. First power up. And we have lights on for the auxiliary. Let's take all this off. Subsonic is making a thump. Speaker 1. I don't know if you hear that click when I hit the speaker button. That's DC current coming out of the back. And I remember when I measured before I just started working on it, I measured coming out the back. I measured 65 millivolts on one channel and 75 millivolts on the other. So I don't think that was normal. But you can still hear on both channels there's still a DC. Let's turn off all this. Let's set this to 0. Everything's centered. Let's go with source. Feeding it a 30 hertz signal. There it is. Both channels. Okay, let's turn this up. The left channel sounds stronger than the right. Let's give it 1000 hertz tone. Right channel, left channel seems a little quieter still. It's not as bad as it was before. 4 kilohertz, 5, 6, 7, 8. Yeah, there's still something wrong with that left channel. I'm gonna have to maybe look at some of the transistors. Maybe I got a bad transistor in there somewhere. Okay, enough of that. Let's try this. Oh, the tuning up works. Auto works. Now, what the hell was that? Wow. Something's clicking off here. I happen to think it's probably a protection circuit. Got no antenna hooked up.
Qui était séparé. Et c'est tout à fait le contraire de diabolum. Diabolum.
I'm still not getting any signal strength. And once I hit a certain point, it cuts off. It's obviously a protection circuit. And it'll probably oscillate like this for a while if I leave it. pot seems, yeah, is something. Okay, I got more digging to do. Okay, so it's just been idling, and I was going through and checking different things, and I noticed this heatsink is getting quite warm on this side, and this side is staying relatively cool. So there's still something going on with that channel in that power amp. There's an imbalance. Oh, this is starting to get hot. I'm going to shut this off. There's either a shorted or leaky transistor, or an open transistor, or something with the resistors. But I'm going to have to go in and delve into this, because this is definitely not normal. Okay, I think I isolated the problem here. The problem with the power amplifier cutting off and going in protection mode was the balance adjustments for the channels, and I went through and did the settings. The one setting was quite far off. Let's see, which one was it? It was the DC balance adjustment, and what you're doing is you're measuring the voltage of what's coming out at the speaker terminal. And I was, after the amp warmed up, I was getting like maybe 150 millivolts or 160 millivolts, which is way out of spec. It should be 0. So once I got that done, the power amplifier seemed to settle down and smarten up. But I'm still tracing this problem with the weak left channel, and I think I isolated it down to this board. This board is your tone control board, and this one has your bass and treble controls on it, and it's got, from here, this is plus minus 42 volts from the main PCB, the power supply, and they have a little regulator here, and it drops it down to 24 volts, I believe it is, 23 point something, and gives it a plus minus. But the reason I'm thinking this board is I took my scope and I fed an equal signal to both channels, and I traced the signal on the input side of the board. You can't see it on in this frame, but it's way under here somewhere. There's 2 resistors. I probed that with my oscilloscope. Signals are equal, and then I went and I probed the output of this board, which is this resistor here and this resistor here, and this resistor is definitely, the level on this resistor is definitely a lot lower. I'd say it's probably 70% of what this side is. So somewhere on this board, I'm suspecting one of these 2 transistors is leaky. It could be any of these transistors. So what I'm going to do is I'm going to pull this board out again, because I have no access to it from underneath, and I'm going to go through and test all these parts. I remember I did test a number of these resistors with an ohm meter, and they all came out good. It's got all new caps, but I do believe I have a bad transistor in here somewhere. Leaky diode or a leaky transistor. It's just barely in there working. So I'm going to go work on that now. Okay, so I've been troubleshooting here quite a bit going on. I've isolated the problem to this board. The one thing I did find, that there's 2 FETs or FETs hanging on the inputs. Let's see if I can find them here. Yeah, there's one here and there's one here, and they're coupled with these 2 diodes. I checked these diodes are good. I replaced these diodes actually because I just wanted to make sure that there was no leakage in one of those. But what I did is I swapped FETs from one channel to the other, and the problem went along with the FET. So now I have the problem in the right channel instead of the left. So what I'm going to do is I'm going to order 2 of these new FETs. They're 2 SK364s. Pop them in there, and hopefully I've got the solution to my problem. So I'll get that ordered and just have to put everything on pause until that arrives. Okay, it's now 12 weeks later, thanks to the magic of video editing. I ordered these FETs that long ago, and it took that long to get here. There's 3 of them. So I'll pop these in, get this back together, put a front on it, chassis, get it up and running, and we'll do a test to make sure we have both channels back where they should be. Okay, got it back together, but I'm still running into some troubles here. I got a dirty switch. Which one is it now? This one here, the tone defeat, is dirty. I'm still getting muted left channel. Here's left channel. Here's right channel. And I think one of these switches is dirty. But anyways, I got another problem that I just discovered. Subsonic filter. Yeah, where are we here? If I press it, you can hear the power amp swing to one of the rails and back again. You hear that 60 hertz? You can hear the transformer getting loaded too. So I'm trying to figure out, I put the receiver in mono, switch it so both channels, I got the balance centered, and if I do this again, it's still the right channel, not the left. Let me disconnect the right channel speaker. Okay. Oops. What's going on here? I had it grounding on the chassis. So now it's gone. I can hear a thump out of the left. So it's not as pronounced. You hear that thump? I don't know if the microphone's picking it up. So I still have more troubleshooting to do here. Take the mono off. Still doing it. Every time I press this button, I can hear that transformer getting loaded. So it's got some DC component going through here somehow. I'm going to have to figure out, this is the Subsonic filter. So I'm going to have to read through the schematic and figure out what's going on with this. I don't have a good schematic here. It's so printed so tiny. But I'll figure it out. Alright, I think I'm starting to make headway here with this amp, or this preamp. Let me just get put this in here so I can explain what I'm finding. This switch here, 509, is a subsonic filter. That's the one that's making the big thump on the speaker output, so when I do that. And actually this switch is drawn wrong. It should be, this wire should be connected to the center, not the extremities. But anyways, the purpose of the switch is to apply a voltage to this junction. When the switch is open, we have this path here. We're going through a 1 meg ohm resistor, and it goes up to the positive rail. When you close the switch, it connects through this 47k ohm to the negative rail. So depending on the position of the switch, this is either positive 20 volts or negative 20 volts. And what that does is it turns these FETs on or off, and the FETs control the this bandpass filter. This is a subsonic filter right here. Either it's on or it's off, depending on the position of the switch. Now I couldn't figure out, this is the wrong channel to be fair, so I'm just going through here. So this line comes down to this FET, and this is the subsonic filter for this channel. Now I'm getting a lot of DC on the output, DC offset on the output of this preamplifier, and it's up like around 2 volts, which is way out of lunch. I can do the measurement here and show you, but I'm trying to figure out why is there a voltage on this output. I checked all the transistors, and when I switch the subsonic in or out, it makes no difference on these pairs, but I'm finding it's coming through here. And well, I'm thinking, well, how can it come through here, because there's 2 blocking capacitors? I think one of these 2 capacitors is bad and letting DC through. So let's just go ahead and check. Let's check the output on C520, and then we'll check R536 input and output. So this 520 is over here. You can see the meter there, can't you? I'm getting 0.5 volt. So when I press the button, I get a wild swing of over 2 volts, and then it settles down, settles at about 0.5 volt again, and then when I take the switch off, I get another wild swing up into the positive area and then back down to negative. So that's on this capacitor here. This 270k ohm resistor is right here. Same thing. If I, can you see this? Check this out. Same kind of swing, same voltages. Turn it on, it swings up, or swings down actually. Swings to the negative rail really bad. So swing into the negative rail tells me it's hard to work in confined areas here. One of these 2 capacitors has to be leaking. They're passing current. 508, 506. And those 2 capacitors are right here. This one here and this one here. Let's see. What I got on this one. Okay, let's check the other side. Should be at 0. If it's a DC blocking capacitor, you'd think it'd be at 0, which it is. And it's climbing. It's charging up. Okay, let's check the other capacitor. So in hindsight, I guess those 2 FETs that I changed out were nothing wrong with them. I think there was a bum capacitor in the circuit that made me believe one of them was bad or leaky. I got nothing on that one at all. Let's go to the other side. Here I got a wild voltage. Okay, so what I'm going to do is pull those two caps out and test them. And now that I got it all back together, it's going to be have to take it all apart again one more time. So I'll pull those two caps out, test them, replace them if necessary, and that should be the end of this. I'm just about ready to throw in the towel here, but then I made a breakthrough. Having spent many hours on this thing trying to figure out this preamp, when I enable the subsonic filter, I get a big DC thump on the speakers. And you can hear the amplifier going in saturation. And if I put a meter right on the outputs here, right here, and right here, right on this capacitor, this 47 microfarad capacitor, I can measure a voltage swing of up to 2 volts. You know, positive to negative, whatever, it doesn't really matter. It's just a big, huge voltage swing that causes the output amplifier to go into saturation, and that can't be right. So I've been troubleshooting this thing inside out, upside down. I've been replacing transistors. I replaced the 2 output transistors. I replaced this driver. I replaced this differential pair. I replaced these FETs. This FET here and this FET here, and nothing I did made any difference. I measured all the components, everything came out good. So what I did is I thought, okay, well, let's start from ground zero. What I did is I removed this FET and I removed this FET from the circuit completely and tried it out. And when I hit the subsonic filter, bang, I got big voltage swing, even worse than before, than what I was dealing with. So I was, what's going on here? Because there's nothing connecting. If you look at this diagram, this is the positive rail for the preamp, and this K here, this is the negative rail for the preamp. So what this does is it taps off a voltage from the positive rail, goes through a 1 mega ohm resistor, capacitor to ground, and to the switch. The other side of this switch has a 47K resistor that taps to the negative rail. So I got negative here, positive here, right? This switch is drawn wrong. So what happens when you enable that switch, it shorts these two wires together, and this line goes from positive 22 volts approximately to negative 22 volts. And that would in turn is supposed to turn on these FETs. Now, with these FETs removed from circuit, it's a dead end. This current path is a dead end. It has nowhere to go. I couldn't figure out why. I was still getting the big thump when I had the FETs removed, because there's nothing connecting this switch circuit to the rest of the preamp. I couldn't figure it out. And then what I did is these two capacitors here, there's a 6.8 microfarad 25 volt here, and there's a 6.8 microfarad 25 volt here. This is part of the subsonic filter. When you switch it in, the FETs turn on, and it switches in this this RC network here, and it kills the lower frequencies. I removed these capacitors. These are brand new capacitors I put in, brand new. I removed them and I tested them, and I'll show you what I found. See, I'll zoom this in so you can see it. So here's the capacitor. I'm going to hook it up, and it measures 6.4 microfarads like I'd expect, 2.8 volt ohm ESR, which is okay, it's good, it's a brand new capacitor. Now if I go to DC resistance, I get about 15 megohms. leakage on those brand new capacitors. That 15 megohms was enough to upset this circuit. It was enough to charge up those capacitors. There's other capacitors in there, and it was enough to charge them up to a voltage of, let's say, 1.5, 2 volts or whatever. And then when you enable that switch, it would dump that current into the circuit somehow. So I think this is part of the problem. I got these new capacitors I put in are causing this saturation in the output. Now, what do I do about it? Well, put the FETs back in. I could dig through the parts pile and find the old capacitors. I doubt they're very good anymore. And put them back in, but I don't know what the solution is here. I could remove the capacitors altogether, leave them out, and have no subsonic feature. Yeah, so let me think about this and what I'm going to do with this amplifier. This thing's been a nightmare. Just for the hell of it, I dug out the 2 old capacitors. I'm going to test them out here. Let's go with this first. And that's one of them, 6.6 microfarad, 1.7 ohm ESR, even better than the new one. Here's a DC resistance, roughly 16, 17 megohms, 18. Not much different from what I put in there, although this cap's probably 35 years newer, so I don't understand. Here's the other cap. This one has a DC resistance of 17 megohms, 18. .5 microfarads, 1.9 ESR, which is a good cap. I might just put these back in and go from there. I still think there's something else that's not right with this preamplifier though. Alright, final test. Turning it on. Soft start should be on. Let's click this. There it goes. Look at that. Can barely hear a thump. I got both FETs soldered in. I got both old caps soldered in. And I'm not getting any annoying thump. It's very quiet, if anything. And I think my problem was I had on the bottom of the board, I think I had a conductive blob of something that was shorting out between traces. These boards are not very good. They're really poor quality printed boards. Or I don't know how they do those. I guess they're but they're etched really poorly. But in the solder mask isn't that great either. But that's good. I got this. I cleaned these switches. They seem to be working good now. Let's wrap this up, put it back together, and start doing testing. I've had enough of this. Okay, I'm going through the tuner alignment, and I ran into a problem. I came up to one point where I had to adjust the tuner strength meter. There's this meter here, this LED display. There's one LED here on the far right, which is, what does that correspond with? I don't even know anymore. I think that's the stereo light. And then there's another amber light here that's for tuned, when you get a tuned station. And then there's a series of 5 LEDs to display the signal strength. So I'm just going to go through and check this. I have the power supply. I got a 1000 ohm resistor in series with this power supply. I'm putting 6 volts on it, so just enough to light the LED. And I just want to test. Okay, that's the stereo. That's a green LED for tuned. And this first LED works. Not the second. Not the third. Well, that one works. Okay, I got two. What is going on here? Okay. So I think I have a break on the bond wire on the second LED that's preventing this tree from working. They're all in series. Let's see here. Two. Well, this one's not working either. That's the number 2 and the number 3 LED don't work. Getting nothing on those two LEDs. Oh boy. So I think I'm going to have to crack this open to see what I can do with it. It has some kind of coating on it. If you can see that, I got a reflection there. There's a reflection. You can see the coating that they put over the LED chips. And I went and looked with a lens. I can't really see anything. I'm going to pop this thing open. All we can do is more damage than what it is, right? It's just held together with 4 posts that are plastic and they're mushed down with heat. So I'm just going to crack each corner off. Okay. Now we should have a better look at this. Okay, so there's a bare board. You can see the stuff they put on here. Some kind of a encapsulant. What I'm going to do is try alcohol on this and see if that stuff comes off. Let's let that soak for a bit. I think if I can get the stuff that they put over top of the LEDs washed off, what I'm going to try doing is I'm going to try soldering that bond wire, if that's what I can see the problem is, back to the board. Otherwise, I'm looking for a new display. This stuff, I don't think this stuff is coming off. Might have to try something more aggressive. No, I don't think it's coming off. When I look through the lens, I can see the encapsulant around the LED chip die, and I can see cracks like it's aged and dried out. Yeah, this is not coming off. I'm gonna have to try something else. This stuff here is pretty aggressive. It's probably banned nowadays, but who knows? I'll give it a try here. It's got some strong alcohols in it. Let's give that some time to soak. Try not to get too much light because I don't want to flood the camera. I don't want to give reflections either. See if that worked. No, it's not touching it. Okay. Might have to move to a petroleum-based solvent. Like on that one, stopped working. It was working. Okay. I don't know why they would wire them in series like that. Let me hunt up some more solvents here. So I got something I'm just going to throw out there and try. I don't know. Alright. It's not a solvent per se, but it's petroleum based, and we'll see. Ooh, stinks. I hate that stuff. Let's see what it does. I could go get some lacquer thinner, but it would probably remove the solder mask too. I was thinking about this, what I'm going to do if I can't solder the bond wire back onto the pad, if that's what's wrong with it. I can't really get a good look at it yet. Is I might be able to scrape these 5 diodes off and just put some tiny surface mount diodes, and just glue, solder them in there, and hopefully get them aligned pretty enough so that it's straight, and I'll resurrect this display. But that's a last resort, I guess. I doubt very much I'll find one of these on the net. And if I do, it's going to be used, and the guy's going to want, you know, good money for it. So I don't know. Too cheap to pay him. I don't think that's touching it either. It's not even moving the... Okay. Whatever they coated those diodes with is... maybe it's a silicone-based product. Not really scraping anything off. Oh yeah, there it is. It's hard. It does scrape off. Seen on a lot of HP, older HP electronics, they do this with the LED dies just mounted directly on the PCB board, and then they mount the bond wires. But they don't coat it with anything. I guess the you know, if it's mechanically protected with a cover, you shouldn't need to coat it. Yeah, this is not going to play nice. You might have to get 5 LEDs and try and solder them onto that board. Hit that bond wire. It's encapsulated. Okay, I'm going to get some LEDs and solder them on. Alright, let's see what we can find here. Why is there chips in here? Okay. Ideally, what I want is chips. Ones like this, small. I don't know. The brightness of these LEDs. Come on. Yeah, it's pretty bright compared to... Where'd you go? Come back here. Okay. Come on. Plus it has kind of a frosted... This one's clear. Let's see what this one does. That one doesn't work at all. Nice tiny ones. Not only they gotta be the right brightness, but they also gotta be the same color. You get different colors of greens. That one's a little big though. I might have to, it's like picking through fly shit here, but that's got a nice color. It's not very bright. Okay, I'll pick through here and see if I can find 5 suitable candidates. You don't need to watch this. Okay, I got 5 LEDs selected. They're ball green, and just want to make sure that the orientation of some of these is right. Let's just check a few of these. Oops. Come on, I know you're working. Okay. So that side's negative. Okay. I have to keep all my negatives to this side because when I did the test, the negatives are on the right. So I just have to keep remembering that. Negative to the right. You notice these LEDs are quite a bit brighter than the ones on the board already. I think there's a way to turn down the brightness of the display with the... It's driven by an AN6875 chip. It's got 5 outputs and 1 input, and I think it has also a current limiting part on it too. Well, let's try, get these test probes out of the way. Let's try replacing one of these. Let's take a stab at this one. Let's get this off. If it didn't work before, it doesn't work now. Okay. Hope I'm not taking off the copper. Let's have a look. The chip is being difficult. Let's scrape it off. But it's bonded there with, I don't know, it's a silver solder they use or what to bond the chip to the copper. Or actually gold, because these are gold-plated connections. Okay, I think that's going to be good enough. Let's put some solder down. And clean my tip. I'm going to use the biggest chisel tip I can find. There. Take another look at this. Okay, perfect. I got both pads tinned. Now I need my chip LED. Where is it? Which one were we going to use? This one. Okay. Better if I wasn't doing this on paper. Okay. That's the right orientation. I think it's done. Let's get a... Yeah, look at that. Okay, so 4 more to do. I'll repeat the process and I'll come back when I'm done. Show you it. Alright, I think I got it. It wasn't easy, especially with that big chisel tip. But they're on there and they're working. So I'm just going to clean up some of this flux. I'm not happy with my selection of LEDs because some LEDs have the chip in the middle and then some have them off to one side, so that the spacing of the meter is going to be a little bit off. It's going to look funny, I think. Let's just clean this off. And I'll show you. Okay. One, two, 3. I don't know if you can see the 3 there. They're pretty dim when you got 3. I should turn up the voltage here. Maybe I can get a bit more. Turn it up to 10 volts. Yeah, 9. 9 should get me all of them, wouldn't it? You would think? Barely. There's 4. Let's turn it up. 12. 12 volts should get all 5 LEDs. They're all in series. So here, let me just turn this light off. And then you can see how they're not evenly spaced. And this last one's a clear, and it's really sharp compared to the other ones. The other four are dull. But unless I bought brand new LEDs, what happened there? Did I burn it out? What's going on here? What happened? Okay, I'll put the cover back on, wrap this up, put it back into the tuner. I'll clean the face of this first. Actually, I might do is I might take a Sharpie and go around those LEDs just to clean up some of the, make it darker because of high contrast background. No, maybe it'll be all right. Okay, just a drop of hot glue in each corner just to hold it in place. Don't need a lot. I'm gonna put it back in the board. There we go. Yeah, if I was a little more patient, I probably would have ordered LEDs, brand new ones, exactly the kind I want with the clear, and you know, they'll all be the same model or same part number, and then they have the same brightness. So I probably would have had a better result, but this is good. This is going to work. Alright, clean that up, and then I'll get this back in the receiver. Okay, they're all back together, time to test the display. So we got it hooked up to speakers, power. Oh, look at that. Why do I got this now? Got 3 bars. Okay, gone through the tuner alignment on the FM, and it seems to be working great now. Picks in station's pretty good. All the indicator lights are working. These lights are still bright compared to the original 2. You can see that on the camera. It's quite a bit of difference. I might go and look at the data sheet for that chip, that AN65 whatever it was, and see there was a resistor tied to one of the pins, and I believe that was probably a current limiting. This resistor here, R386, goes to pin 7, and it's tied in with the power. It's tapped off the power. So I think that resistor sets the current for these 5 indicator lights. And it's a 2.2K. Maybe I can change it to a 3.3 or something. I don't know. Maybe I'll have to look at the data sheet for it and see where I can change that to dim those lights down a bit. This thing should scan on its own. I don't know how to do that. Auto. Here we go. Auto.
So when he says he in a love song, it
Yeah, it's working great now. I just got a chunk of wire for an antenna.
Allora, continuiamo con musica o vuoi parlare un po'?
It's Cindy next time.
It's working good now.
Try that, yeah.
I'm in.
I'm in for the win.
Time to put it all together.
Thunder rolls.
So I'm putting it back together here, and I got these buttons. They're all like sticky feeling. And if you push them out and look, I don't know if you can see any of that. Here. There's all kinds of schmegger around the sides of the buttons from you know, dirty, sticky hands. So I think I might just pop all these buttons out and drop them into the ultrasonic cleaner, and that'll clean that up. And then once the buttons are out, you can get in with a Q-tip and you can clean the hole with some alcohol, get rid of that sticky schmug. It feels really, ugh. The last thing I want to do on this receiver is change the main filter capacitors, because I pulled one out the other day and I checked it, and it was just terrible, because it you know, they dried out with age. So let's do that today. These are 4700 microfarad 50 volt, and if I connect them to the meter, let's just have a look and see what it says. So I'm getting 3500 microfarads and an ESR of 0.8 ohms. No, that's not ESR, sorry. Let's get ESR going here. The ESR is 0.03 ohms, which is good, but it's lost significant capacitance, 1200 microfarads, or sorry, yeah, 1200 microfarads from the 4700 originally. It's down to 3500, 3600. DC resistance, which is kind of irrelevant in a power supply cap, but it's still at 280 ohms, which is a fail. So this is leaking internally. Let's see, I can't remember what the power supply voltage was on this. 35 volts or something, or 40 volts. What was it again? Anyway, it doesn't matter. It's these caps are aged and dried out, so we're going to replace them. We got our new ones. Came yesterday. I got like it wrapped like a sandwich here. What's going on? The one thing, let's get a good look at this. The one thing you want to pay attention to in ordering new capacitors is the physical size. The diameter has to match. Otherwise, chances are of it fitting back on the board is next to nil if you have components tightly in there. So you want to have your diameter the same size as your old one, and you also want to have the height the same if you're running into clearance issues. If you don't have any clearance issues, you can make this new capacitor higher. So you get into the data sheets, start looking around, And the one thing you have to keep in consideration is the working voltage. You can't go less than 50 volts if the originals are 50 volts. You want to keep that at 50 or higher, or you might have to jump up to a 63. It's not necessary, but you can do it. And another thing is you can increase the capacitance up to a certain extent, because when you start increasing your capacitance too much, the physical size gets too big and then it won't fit. So if you pay attention to the dimensions of the can and you select your new one to match those dimensions, then you can scale up your microfarads to however high you want. If you want to go to 10,000, you can if it'll fit. So basically that's all there is to it, is just selecting the right capacitor and getting the size to fit. Reading the data sheets. So let's put this in. And you want them fitting tightly to the board. The reason you want to replace these old filter caps once they start losing capacitance like that is because when you start loading the amplifier heavy, you're going to start hearing 60 hertz hum or 120 hertz hum in your speakers, because the capacitor is no longer providing that capacitance, the storage capacitance of electricity. You know, it's like a tank, right? And if this tank is smaller than it's intended to be, it won't handle the current. So let's go through, I'll change all these. What does this one read? This one's a little bit better. It's reading around 4,000 microfarads. Same ESR. But you can feel that they're kind of dried out. They feel light. These ones, they got a little more substance. They got some weight to them because they're not dried out yet. They're brand new. I know that's not a scientific way of checking capacitors, but it's something you learn over the years. Okay. Make sure they're orientated properly. You don't ever want to put a cap in backwards, because it'll be like a dead short to your power supply. If you reverse the current on a capacitor, electrolytic capacitor, you'll quickly know it because it starts drawing current instead of blocking current. I should actually do a demonstration on the channel. What happens if you reverse polarity of a capacitor, and what happens if you over voltage a capacitor. They're not very forgiving. Alright, I'll do the other two. Okay, I got them in. I'm going to trim off the excess leads. It's poking down quite a bit, and I don't want these to make contact with the steel bottom cover. That'd be a dead short. So just trim off a little bit of the leads. So since I'm wrapping this thing up, I just want to talk about the amp itself, the receiver itself, and some of the problems I ran into with it, and the build quality. The build quality is pretty good, except for one thing I was really not pleased with at all, was the quality of the printed circuit boards. They have, if you look at the printed circuit boards carefully, they're pretty crude. You know, by today's standards, and I think they were a shortfall back when this was built. I think they got away with the printed circuit boards. The reason being is the traces are not well defined, and the holes through the board were oversized. I noticed in a lot of spots the hole was, they have the pad, and then they have a hole which is oversized, so you have around that hole you have a really thin film of copper that you're supposed to solder to, and what the result was is sometimes it's difficult to solder because you have really no copper to solder to with the lead, so you end up bridging the copper and the lead with solder, and it wasn't good, because I went through this receiver and I found a lot of cracked solder joints, and that was the main thing that screwed me up in troubleshooting too. I had one spot where the copper traces are too close together, and I had a short, but I couldn't visually see it, and until I took a tool and scraped between the two, it actually I wouldn't have found it otherwise from visually looking at it, because it was just a mess. Other good things about this, they put some thought into the design of the amplifier. You got two completely separate power amplifiers, fed by separate transformer windings. They go into a bridge rectifier here, bridge rectifier here, and then they have their own filter capacitors. So they got two independent power supplies. Even though they share the same transformer, they have two separate windings, one for the left channel, one for the right channel, which is good. Another good thing is it's all discrete, easy to work on. You know, these are not Darlingtons, these are just regular transistors, which is another, in my book, that's another good thing. Sometimes when they put Darlingtons in here, I'm not, I shouldn't say this, but I'm not just, maybe I'm biased, but you know, Darlingtons aren't my favorite, and I like to see discrete components in here, especially when it's you know, the drivers and the Darlingtons, and not transistors. Everything else is working good. I spent a lot of hours, replaced a lot of caps. Every single cap in this unit was bad on these TK caps, and the other caps, let's have a look at them. These TK caps, a lot of them are garbage. Let's measure one for example. It's 4700 microfarad, comes up at 415, and it's got a 0.16 ESR, which is high. 25, it should be around 0.12, not 0.15. That's not one of the worst ones. I've had other ones in here that are bad. Let's check this one. It's 100 microfarad, and it measures at 71. And I'm getting a 1.6 ohm ESR, when it should be around 0.3. So yeah, a lot of bad caps. So I replaced all the caps. Did the repair to the signal strength display for the tuner, and filter capacitor upgrade. So we should be good for a lot of more years. This thing was a basket case when it came in. It was a total basket case, and it was on life support when I first hooked it up and tried it. It was sound pretty crude, so I think I got it nailed. And yeah, they got a nice receiver here. So we'll put it into service and see how it performs. Other than that, I got nothing else to do other than just assembly. I got the front panel all cleaned up and put together. I don't know if you can see that. Zoom out. Yeah, it's looking good. I'll put the buttons back in because I was changing the capacitors. Those rods are in the way. Put these back, put the covers on, and we'll try her out. Thanks for watching.